In the previous lecture, we saw that we can dynamically allocate memory in the heap for objects. So of course, we can also dynamically allocate memory for arrays. A dynamic array is an array whose size can be determined at runtime. Now, sometimes we don't know at compile time how big that array should be. So let's say I have some array that keeps track of the scores for your students. Well, one classroom can have more students than another classroom, right? Then you can think, okay, well, maybe the most amount of students in any one of those classes can be 100. Then that's fine. You can create an array of, let's say, 100 integers or of size 100 at compile time. But let's say one class is only 5 students. Now you have this huge array in memory, but you only use 5 spots, right? You only use 5 integers out of 100. So you have this huge object in memory, but you only use a small amount of memory that was initially set aside. So it's kind of a waste. That is one reason why you would go and create a dynamic array instead of creating arrays as we have done it up until this point at compile time. It's really optimize the memory usage of your program. Okay, it's going to allow you to specify at runtime the size of the array, or in other words, how many elements that array should be able to contain. Okay, so how do you allocate memory for a dynamic array? Well, you use the new operator again, followed by the variable type as we've done it before. So new int, new float, or new myStruct, for example, and so on. Because again, a struct is also, and the same with a class, those again are custom types, right? So you can create arrays of those as well. Of course, we want to specify the size for the array. So after the variable type, you have the subscript operator, and then with dynamic arrays, you typically have a variable for the array size that you specify in there. Now, if there's actually space available on the heap and that operation succeeds, then that will return the address of the first element in the array object, and we can then assign that to a pointer. Now, we've already discussed arrays and sort of how they work in memory, right? And that is the same thing here, but the main difference is you don't have an array called demo array or X array or something like that. So in other words, you do not have a variable name which represents that object in memory. So you need to access it in some way, and we do that using the pointer. Now, to deallocate that memory, you'll use the delete operator followed by the subscript operator, again leaving it empty. So you want to add an index or subscript in there. It's just the opening and closing square brackets followed by some pointer name, such as array pointer and my pointer and so on, whatever you call your pointer. And then of course you want to make sure to reassign that pointer or redefine that pointer after this deallocation operation, or set it to null pointer. Otherwise your pointers are undefined or dangling, as I explained in some of the previous lectures. Now in this example, I'm just doing a constant integer, which I'll call size, and I'll set that to 5. Then I have a pointer to an integer called array pointer, and I use the new operator. Now again, we have to specify the type, so I specify int. We want to create or set aside memory for a dynamic variable or object, in this case an array. And of course we have to specify the size, so I just add the size in here. This can be a regular variable as well, and then at runtime you can ask the user how big do you want the array to be. Then we do the console input, array pointer, and maybe we specify index 0, again using the subscript operator to do input or to store a value for that element. Now I'll notice an interesting thing here. We use the pointer name, array pointer. Remember once more that the array which is on the heap does not actually have a name, as I explained. And also in previous lectures I explained that you can use the subscript operator with the pointer name, and if that pointer points to some array, it's basically the same thing. You can either use the array with the pointer name or with the array name, again if you have that pointer pointing to that array. So I explained all of that in detail in those previous lectures, and that comes into play right here, as you can see. So we are not actually using an array name, we are now using the pointer name with the subscript operator either to read from or write to that dynamic object which is now on the heap. And as I explained later on, we simply go and delete that, and then we make sure to redefine that pointer. Okay, just a quick example for you. I have an integer called array size. I do console output, enter the number of scores to be stored in the array, and then I do the input. So as you can see, I'm not specifying what the array size is going to be at compile time. This is a runtime thing. I have a pointer called array pointer to an integer. Here I go and create a new dynamic array of the size of the user specified size. And you can see this again is done after the input. And here you can do a few things. So for example, I do console output, enter the so many scores, however many the user entered, right? Then I simply do a for loop, set I equal to 0, if I is less than array size, increment that. Then I do console input, cin, and I do array pointer. Again, we don't have a name for the actual array for that dynamic object, right? We can only access it using the pointer, and as I explained in previous lectures, you can use a subscript operator with that pointer. So I just do that here, array pointer, subscript operator, and I pass it I. So I'm going to enter a couple of values like that. And then of course you can do something with that. You can go and sort it and then print it out or something like that. Now for this I've kept it concise as I can, as I do with most of my examples. I don't want to get bogged down into searching and sorting and all of that stuff here. I just do console output and then I print the scores out again. Once I'm done with all of that, I make sure to go and delete or to deallocate the memory pointed at by this pointer, and then I simply redefine array pointer, in this case to null pointer, and then of course we do that return 0. Build and run that. I'll just do 3. You can separate these inputs using a space, so we do 5. Just enter a few values, you'll see the scores are, and they'll print out just like we entered them. So again, I'm not doing anything specific with those scores in this example. It's just a quick example to show you how to dynamically allocate an array. Alright, so I hope you found this useful, and I'll see you in the next lecture.